Hello, students. Ladies and gentlemen, today we are going to begin, without a doubt, the biggest topic that you will ever have in school, in any grade level, any school. This is the biggest topic you will ever have opportunity to learn about. So what topic is this? The universe. That's right. Today we begin talking about the universe, the biggest topic in the universe. And as we talk about the universe, we're going to be exploring some of the stories regarding the origin of the universe, the expansion of the universe, and the future of the universe, as well as various features of the universe. So let's begin exploring the universe. And as we do so, there is a theory which you probably have heard about already. And this theory has to do with the beginning of the universe and helps to explain a lot about what we currently know about the universe. And this theory is called the Big Bang Theory. How many of you are familiar with the Big Bang Theory? Now, I'm not talking about the television show, The Big Bang Theory, but rather the actual Big Bang Theory. And the Big Bang Theory suggests that the universe began with an explosion from a single point. Now, we're going to spend some time exploring this theory today and just how in the world do scientists even come up with an idea like this? Some of you might be thinking as you're writing this in your notes, the universe began with an explosion from a single point. How in the world do we know that? Scientists today believe that the universe is over 15 billion years old. And, the oldest human in modern times is just a little over 100 years old. So how in the world can we even propose this kind of a theory? Well, let's talk about the theory first, then we'll talk about where the theory came from. I want you to imagine something which always boggles my mind. The universe began with an explosion from a single point. Now, we need to take it literally because it is meant literally. A single point. I want you to think a little bit about geometry here. You know that you and I are three-dimensional creatures. We have a height, we have a length, and we have a width. And some of us, like me, have a bigger width than others. But we are three-dimensional creatures, and we live in a three-dimensional world. Now, scientists since Einstein have agreed that we really live in more of a four-dimensional universe because time is one of those dimensions. So as our three-dimensional bodies pass through time, and all you have to do is look at the clock, and the clock is always moving forward, we are living in a four-dimensional universe, or at least that is what our perception is of the universe. So when you think of three dimensions, length, width, and time, you can measure those dimensions and come up with a volume, etc., and calculate density as we did at the beginning of the year. But I want you to think really carefully here about this term, single point. You've made some graphs this year. You know what a coordinate system is with an x-axis and a y-axis. A single point has no dimensions. A single point, by definition, has no length, width, or height. It is an infinitely small single point with no dimensions. So think about this for a moment. If I were to take a single sheet of computer paper, this computer paper has a height and a width and a length to it. It's very thin, but it's got three dimensions. Now, do you think it's possible to take this single sheet of paper and crumple it up to form a single point? A single point having no dimensions. Now think about it. If this is a single sheet of paper, and as hard as I squeeze this single sheet of paper, you're still going to be able to measure it, length, width, and height. It still has three dimensions. This is not a single point. I could get a vise, and squeeze it with a vise and get it smaller. But guaranteed, this single sheet of paper is still going to have dimensions. What the Big Bang Theory suggests is that not just this single sheet of paper, but all of the matter in the entire universe began as a single point. A single point with no dimensions, no length, width, or height, but that the universe began with a single point, dimensionless. Think about that for a moment. The Big Bang Theory suggests that the matter of the entire universe was present at the beginning in a single point. This single point contained all of the matter of the present universe. Now, thinking about this single sheet of paper and the impossibility of a human being to squish this down to a single point, just look around you. Imagine all of the matter just in this room, much less the matter of the entire Earth, much less the entire solar system, much less the billions upon billions of solar systems that there are in the universe. That's a lot of matter. So it seems, it seems unusual to conceive of the thought that the matter of the entire universe could be condensed at some point in the past into a single point with no dimensions. That, if it doesn't boggle your mind, you have a bigger brain than me, because it boggles my brain to even think about that. But more than that, the Big Bang Theory also suggests that the universe is expanding in all directions. Expanding in all directions. Now, I mean, if you look outside, you may notice that, the clouds might be moving, and the sun is going around the earth, and, things are moving, but the entire universe expanding? How in the world do we know, or can we even suggest that the whole universe is expanding from this single point at the very beginning? Well, here's the surprising thing. We know all of this because of little duckies. That's right, little duckies give us the answer to this unbelievable thought. You might be looking at me and saying, what in the world is Mr. Skirps talking about? I think he has truly lost his mind. No, I know exactly where my mind is. Well, actually, I don't. Nobody really knows where the mind is. I know where my brain is, but that's a topic for another day. No, seriously, look at this duck. If you look at this duck swimming through the water, I'm going to ask you some questions. Which way is the duck swimming? Is the duck swimming from left to right, from right to left, from bottom to top, from top to bottom? Which way is this duck swimming? Yeah, I'm sure you guessed it correctly. By looking at this picture, you know that the duck is going from left to right. How do you know that? You look at the waves. The waves are all bunched up in front of the duck and all spread out behind the duck. You know that intuitively, but how in the world can this tell us that the universe is expanding? What is going on here? Well, remember what light is? An electromagnetic waves? Oh, yeah. Light is an example of an electromagnetic wave, and waves move and behave in certain ways. One way is that in the direction of movement, just like in water, waves get scrunched up together, and in the opposite direction, they get spread out. So, what does this mean? Well, we know which direction something is going in the water, like a little duck, based on the position of the waves relative to one another. All right, so explain more. Well, how many of you have ever been on the side of a road and you hear a police car or an ambulance or something with a siren going by, and it sounds something like this? That wasn't a very good impersonation, but I think you get the idea. That is something called the Doppler effect. It happens with water waves, it happens with sound waves, and it also happens with light waves. Look at our little space ducky here. Which way do you think it's moving? From left to right or right to left? And I know you know the answer. It's moving from left to right. How do you know that? Because the waves in front of it are all squeezed together and the waves behind it are all spread out. So, what does this tell us? It tells us the duck is moving from left to right. Notice what I've done with the waves. They're now colored according to the colors of Roy G. Biv. Red wavelengths are longer than blue wavelengths. Or more specifically, the violet wavelengths are squeezed together real close together, and the red wavelengths are spread further apart. So, this Doppler effect, as we're going to unpack now, again, happens in water, happens in sound, and it also happens with light. We're going to talk a little bit about the Doppler effect, and I'll show you how and why this has allowed scientists to develop this thing we call the Big Bang Theory and all of those parts of the Big Bang Theory that I mentioned earlier. So, the Doppler effect is the apparent change in wavelength due to the movement of an object. So, again, in the case of a police car, if a police car with a siren is moving toward you, you hear a higher pitch. And when it's moving away from you, you hear a longer pitch. And I'm sure you're loving my sound effects here. And as it's moving by you, you hear the range in wavelengths changing. That's called the Doppler effect. Raise your hand if you've ever heard the Doppler effect in action. Yeah, all right. So the Doppler effect happens with water waves, happens with sound waves, and it also happens with light waves. So let's talk more about the Doppler effect. Again, we can tell just by using our ears whether something is moving toward us or moving away from us. We can hear it, but we can also see the Doppler effect. Because you see, when an object, a luminous body, an object that's giving off light, is moving toward you, the light waves are squeezed together, and you see the wavelengths squeezed together in the form of light that is more blue. When an object is moving away from an observer, the wavelengths are spread out, and we see it with our eyes in the sense that the wavelengths are more spread out and it will appear more red. So looking at the color or the apparent color change of an object can tell you whether an object is moving toward you or moving away from you. Just like the illustration of the duck in the water or the police siren moving toward you or away from you. So this is the Doppler effect. And you might be wondering, if you've never seen the TV program The Big Bang Theory, this main character, whose name is Sheldon, is actually dressing up for Halloween as the Doppler effect. And you can see the change in wavelengths on his shirt, but that's kind of a silly thing. But let's talk more about the Doppler effect in terms of light at this time. There's something called red shift. The red shift is when a spectrum of light is shifted to the red end of the spectrum. And if you look at the picture here, here's what's going on. We have an object. An object in this illustration is moving from left to right. That's why the wavelengths are squeezed together in the direction it's moving and spread out in the opposite direction. But we would see that as the object having a red shift in its spectrum. The object will appear through a telescope that it is, and with a spectroscope, as we have had experienced, remember those spectral lines, the spectral signatures? Those spectral signatures of elements will be shifted to the right end of the spectrum. So when there is movement away from an observer and the spectrum is shifted to the right, here's the deal. Let's say you're looking through the spectroscope like we did in the lab the other day, and you know the spectral signature of an element is like these lines here. Well, looking at some stars or galaxies that are actually moving away from us, look at these lines at rest compared to the same exact lines of an object moving away from us. See how every single line pattern is shifted to the red end of the spectrum. That is called red shift. And just like the sound waves, just like the water waves, the light waves are illustrating this to demonstrate that something is moving away from an observer. Very important point. So red shift means away. Let's talk a little bit about the blue shift now. As you can probably imagine, same diagram up top here. If an object here is moving from left to right, like the arrow illustrates, the wavelengths in front are squeezed together. Again, the wavelengths in the back are spread apart. So if an object like a star or galaxy is moving toward you, all of the wavelengths are going to be squeezed a little bit together, which will appear like this on a spectral signature chart. If there's movement toward you, here's the object at rest. But if the star object is moving toward you, notice what happens to all of the spectral lines. They're all shifted to the blue end of the spectrum. That is called blue shift. And so here's all three of those diagrams together. Here's the spectral signature at rest. Here's a blue shift, and here's a red shift. Now look at those for a moment, and I'm going to go back to the Ducky picture. And again, I want you to use the duck as an illustration of the Doppler effect and notice how he's moving. In the direction he's moving, wavelengths are squeezed together. Shorter wavelengths are on the blue side of the spectrum. Longer wavelengths are on the red side of the spectrum. So if the duck is an object in space moving and you're over on this side, the ducky's moving toward you, it would appear to have a blue shift. If you're the observer over on this side and the ducky's moving away from you, then the object would have a red shift. So how does all of this discussion tie into the Big Bang Theory? Well, here you go. To put it all together, astronomers have noticed over the last 100 years or so that all of the galaxies in the universe appear to have a red shift to them. Well, what does that mean? What that means is all of the galaxies are moving away from us and away from one another. And so if everything is moving away from one another today, it's getting bigger and bigger and bigger, then what can you say about the past? You can say that in the past, things were closer and closer and closer together. That's how scientists have come up with the Big Bang Theory. We observe that things are getting bigger today. So yesterday they must have been smaller. The day before that they were smaller. Continue that line of reasoning to the very beginning, and there was no space at all. So the Doppler effect, our little friendly space ducky, is the reason why astronomers have come up with the whole concept, theory, and idea of the Big Bang Theory. Now, that's a lot to take in for one day. So think about that as I say, for now, bye-bye.